Good morning, everyone. I hope you all enjoyed those fantastic keynotes. Actually, I say good morning, good afternoon, good evening, depending on where you are in the world. Welcome to my home office. I'm going to be emceeing the architecture track for you this morning into the early afternoon, again, my time. And great honor to do that. I got my nitro cold brew to push me through the next few hours, and I hope you have a nice drink of choice yourself. But first up, we have a very exciting duo presenting an architecture talk. Actually, the title of the talk is Spring for Architects, and we have Jakob and Nate, two amazing presenters from our developer advocacy team. And they're going to be telling us all about how architects can leverage the vast ecosystem of Spring to better help their teams build amazing applications. So with that, I'll turn it over to Nate and Jakob.
Well, thank you very much, Ryan. I appreciate that. And it's a pleasure to be here. I wish we were in person. I guess last year I sort of thought by now we would be back in person, but this is the way the world works sometimes. We're adaptable. So I will also echo good morning, good afternoon, good evening. Pleasure to have you here. We're actually spanning time zones because I'm based in the central United States and Jakob is based out of Poland. So we are absolutely spanning the globe here today with our presentation. So, hopefully the internet gods will work well in our favor. But what we're going to do today is I'm basically going to talk a little bit, and then Jakob's going to do a little demo, and then I'll talk a little bit, and then Jakob do some more demos. And we'll just, ping pong back and forth until we run out of time, and then we'll bleed over into the QA, and you guys can pepper us with questions. So let me dive in. Now, I've been in this space a long time, and it used to be fairly simple, right? We had a monolith, maybe two, and we released semi-annually, maybe it was quarterly, maybe even monthly if we were really aggressive. And we all used to work on the same floor. If you can remember in the before times when we used to be in this thing called an office. And even if we weren't on the same floor, we were within walking distance of one another. But let's be very clear, that's not how things work today. There's a pretty good chance that you don't have one or two monoliths. You have dozens, hundreds, maybe thousands of services. Maybe you don't even know how many services you have. And those services are changing multiple times a day. You've got a globally distributed team, kind of like we are here today. And of course, as an architect, this has never been an easy job. And then you sort of sprinkle in the reality that now we have these massively distributed applications with geographically dispersed teams. And we're supposed to make sense out of all this while making sure our applications are highly available and redundant and failover and all these fun things. And it doesn't help that no organization has an abundance of architects. I've never been in a situation where we're sitting around twiddling our thumbs because we just have too many architects. We don't know what to do with them all. And so that puts us into this situation where I can't be everywhere at all times. No architect can be involved in every single decision that our teams have to make. In fact, we don't want to be involved with every decision. We really have to empower our teams to make good decisions. We really have to embrace this notion of distributed decision making. Now, that doesn't mean we just sort of wash our hands of it and hope for the best and, hey, everybody do a great job. It's our job to step in and establish principles, to put in these guardrails, guideposts, North Stars, whatever you want to call them, to help our teams make good decisions when we can't be there. Now, one of the ways we can do that is by leveraging the power of defaults. And this is a very, very useful thing. In fact, it's a interestingly enough idea that it generated a whole new form of economics. It's this idea of behavioral economics. This was good enough to win a Nobel Prize for the people who sort of came up with this concept. But what it basically says is, instead of relying on people to be this rational actor, which is just not how we are, you want to make the right thing to do the easy thing to do. So if you want someone to do something, make it easy, just fall off the truck easy. As architects, we can do that. We can take advantage of that and we can use that for our purposes. And I know you might be asking yourself, well, hang on a sec here. I didn't realize I stepped into an economics talk. I know we've got a lot of interesting tracks. I, for one, I want to check out this barista track. Now Ryan's got me thinking about coffee. Thanks for that, Ryan. As an architect, we need to yield the power of defaults to our benefit as well. And so what we're trying to do is, whenever humanly possible, make the right choice, the easy choice for our developers, so they basically just fall out of bed and do the right thing. What you realize very quickly when you get into these highly distributed architectures is they all have very similar needs. A lot of things come up again and again and again and again. You need to have good monitoring in place. You've got to have some circuit breakers there for when the inevitable bad thing happens. You have so many services that are changing all the time, and you might break a consumer that you need to use consumer driven contracts to make sure that I didn't inadvertently wreck somebody downstream because I made some kind of refactoring upstream. Probably need some gateways, some streams. You got to figure out how to externalize configurations. Maybe you're doing some functions or some service discovery, load balancing, documentation. I mean, the list goes on and on and on. The challenge for us is I can't be in a situation where every single project team is reinventing the wheel on every single one of these on every single approach. That's just not good. That will make suburban sprawl look like a wonderful thing. And so what we're trying to strive for here is how do we get in a situation where we can just focus on these sort of critical design decisions while at the same time allowing our teams to focus on solving the business problems that our customers really care about, while still making sure that we have covered all of these crazy, weird distributed application issues. Because the other part of this, there's a lot of interesting ways to fail with a distributed app. And so what we're going to talk about here this morning or this afternoon or this evening, depending on your time zone, is how Spring can help with that. How we can help you make good decisions as an architect, help your team make good decisions at a design level, and ultimately just help make sure everybody gets a good night's sleep. At the end of the day, this is about delivering business value to production. That's really what we're judged on. That's how we should be judged. And so we're going to try to show you some of the ways that Spring can help with that. Now, I'm going to start by doing a little 12 factors overview just to kind of remind everybody of how that sort of plays into this. And then this will help expand us into why and how Spring can help us solve some of these problems. So the 12-factor app is something that comes out. Everybody talks about 12factor.net. And really what it boils down to is this characteristics shared by successful apps, at least at Heroku. Now, it's not as complicated as it sounds. Really what we're saying here is you got one code base and version control, multiple deploys. I don't think version control is controversial anymore. At least it better not be, or I'm going to have a bad night's sleep tonight. We want to explicitly define our dependencies. We want to make sure that configuration is separated out from the code. We'd like to have our backing services just be like attached resources. We want to build, release, run, lifecycle. That's just a fancy way of saying we want to have deployment pipelines. We need to be stateless. Now, that doesn't mean there's no state. Obviously, we want state. It just needs to be in a durable backing store. It can't just be in memory. God knows I've written plenty of applications that rely on that. It turns out to hurt really badly. We're going to export services via port bindings. We're going to scale via process. In other words, scale horizontally instead of relying on more hardware. For a lot of my career, I got away with that. You could say, oh, geez, the app's not performing very well. Oh, don't worry, we're getting a new box next month, so everything will be better. We need to start up fast and shut down gracefully. And that kind of goes back to that whole notion of doing horizontal scaling. We want a lot of little things that spin up and then go away when they're not needed. We want dev prod parity. Now, I've never been on a project where I thought it'd be really good if dev and prod were totally different. I really need to add some additional challenge to my job. We need to treat logs as event streams, because I can't just go to a file system because that file system might not be there when I come back. And then we want to run all our admin tasks as a one-off process. Now, I would argue that these are just good design decisions, regardless of whether you are going to build a quote unquote cloud native app or not. I think, most of these are pretty, uncontroversial, at least in my mind. We'll talk about some here real quickly that tend to be problematic. This idea of one code base and version control, multiple deploys, again, not controversial, right? If we're going to share code, put it in a library. Explicitly define dependencies. I can't just rely on something being on the server. If you need it, you got to declare it. I want to separate out anything that changes from environment to environment. Again, these things are going to be spun up multiple times, different places. We want to make sure that we don't have something hard-coded in there. In other words, could you open source an app right now if you had to? Treat your backing services as attached resources so you can swap out local database, test databases. In other words, loose coupling. Build, release, run, again, deployment pipeline. So we build the executable, we deploy it with the right configuration, and then launch it into a given environment. Share nothing. Probably one of my all-time favorite tweets is this one from my friend Stu. If you don't think managing state is tricky, consider the fact that 80% of all our problems are solved by rebooting. He's not wrong. We want to store these obviously in something that's durable, so not the file system, because that system might not be there when I come back. Export services via port binding. So listen on the port for incoming requests. So local host for development, load balancer for public facing. Scale via process. Again, just scale horizontally. Start fast, shut down gracefully. Gosh knows I've violated this before. We don't want to treat these things like pets. They need to be disposable. So start them fast, shut them down fast, ideally in seconds. And then, yeah, you know what? We're going to kill you. We don't need you anymore. Dev prod parity. So how quickly can we get code into production? It shouldn't be weeks, shouldn't be months, which does mean we have to be involved in deploys and things of that nature. We want identical regions. Have we ever not wanted that? I hope not. I mean, I think everybody has had that problem where it works in one region, but not the other. And then you pound your head against the table trying to figure out why. We want the backing services to be the same as well. Again, that shouldn't be controversial. And then again, we need to treat our logs as streams. So can't write to the file system because it's not going to be there when I come back. Challenge there, of course, is just changing where it goes to standard out instead of to some specific file system. And then we route that to somewhere more useful, where frankly, this is a huge win in my mind. We get a lot better tools to actually consume them with. So that's pretty nifty. Again, running our admin tasks is a one-off process, like a database migration. Think of this really as a REPL, if you want to look at it that way. And so we want that to be running in the same environment as our long-running processes. Now, having written plenty of legacy apps myself, you're going to violate some of them. There's a chance all 12, but probably not. You know, the ones that seem to be the most consistent problem makers are explicitly defining dependencies. This is one we tend to whiff on. You know, it's so easy to just sort of throw something in the lib folder and not think twice about it. You know, so do we really need it? I don't know. It works. Don't touch it. Separating out configuration from the code. I have definitely violated this one multiple times. You know, you hard code a database configuration, you hard code, you know, some credentials in there, and you're like, hey, how come we're still seeing the test database? Well, because we hard coded that in. Oops. Stateless, gosh knows I've broken this one multiple times. This is one of those early in my career. It seemed like our default answer for everything was, well, you know what? Let's just stash it in session because that makes my life easier. A lot of applications traditionally have been built around a specific page flow where, you know, page 2 left debris for page 3. And it was super easy for us to just say, throw it in session. It's fine. That way, I don't have to go all the way to the database to find that again. It's much faster. You know, this is before we knew about these things called distributed caches. Start up fast, shut down gracefully. I've written a lot of apps that take far too long to start up because what did we do? We called the database 10,000 times on startup to load a bunch of stuff in memory to, again, prevent us from having to do that and slow everything down because we didn't know about distributed. Well, okay, distributed caches did exist, so I shouldn't be too hard on myself. The problem here is it impacts health checks because the brain that sits in front of whatever you're using is expecting to have 5 instances. It only sees 4, spins one up, asks if it's healthy, and if it doesn't get an answer fast enough, it just spins up another one until you run out of compute. Oops. Dev prod parity. Again, have we ever not wanted consistency here? And the whole goal is how do we shorten that cycle to get code to prod? And I have uttered this phrase in variations, you know, well, it worked in test, but not in dev, or it worked here, but not there. And it's painful. And we shouldn't have those problems, frankly. Now, one of the arguments I've gotten into ad nauseum with various people is, does my application have to be fully 12-factor compliant to be considered cloud native, to be useful in the cloud, to run in the cloud? And the answer, of course, is no. It's a darn good goal, sure, but we have to be ruthlessly pragmatic and understand that if we don't address some of these issues, we don't really get the advantage that the cloud gives us. You know, so if you think about long startup time in particular, well, that makes it really hard to do elastic scaling and self-healing. You know, so you can think of this, if you wish, as a continuum that, you know, kind of the further down this 12-factor compliance we get, the more benefits we get out of these cloud native type applications, you know, but we have to decide what makes sense for our application. How much do we want to invest in it? Now, you will hear people talk about 15-factor app or beyond the 12-factor app, but, you know, it doesn't really matter. If we're going to do these highly distributed applications, we need to make sure they're designed to take advantage of that. And of course, understand that, yes, our legacy apps will fall short. That's okay. We just need to opportunistically refactor them. If I'm building Greenfield, well, obviously I should just go cloud native. I can't really imagine a scenario today where I would want to build legacy code out of the box. That just seems odd to me. All right, so let's dive into some of these things that we need in these highly distributed applications. And let's start with monitoring. If you want to have a thriving distributed architecture, guess what? You need to have good monitoring in place. Otherwise, you have no idea what's going on in your system and you'll just be tearing out your hair. Now, there's 4 primary components to what we mean by monitoring. There's logging, which is just a fancy way of saying, what's your service doing? Now, this is an interesting conundrum I've seen on a lot of projects. We tend to live on one extreme or the other, which is we log nothing at all, or we log literally everything, every entry and exit from every method, interesting or not. And it's hard to find Goldilocks here. But I would say you should log anything that's useful, and I'll let you define what you mean by useful, so long as you didn't put any personally identifying information in your log files. Don't ever do that. And of course, keep in mind that some things by themselves are not personally identifiable, but when combined with one or two other things, all of a sudden are now personally identifiable. Now, of course, tracing is one of the big challenges we face in these heavily distributed applications, because I can't just sneak a breakpoint in and step through the code. I may not even have the code for that service. And so now my call bounces between 5 or 10 or 15 services. So how do I know where things went? Well, that's where correlation IDs become so helpful. Now, speaking of which, you'll be shocked to know that Spring has an answer here. We've got Spring Cloud Sleuth that basically gives us this auto-configured distributed tracing, which is awesome. It covers spans, covers samplings, covers key value pairs, all sorts of useful stuff here. All I got to do is, or it'll add the trace and span IDs to ingress and egress points. It'll instrument those common ingress and egress points, and it'll generate Zipkin compatible traces. This is pretty simple because all I got to do is add sleuth to my class path, and boom, now my boot app can generate trace data. Another key component here is dashboards, which is how do I just say I have a view into the health of my service? And so this is just a series of metrics that we display on a dashboard. But that's not the same as alerts. We want to alert when something goes wonky. You know, the example here would be if you've got a car and it'll flash a message at you when the tire pressure is low or when it needs an oil change or something like that. And maybe you get a diagnostics thing from wherever you take your car to be serviced. That's a printout of the sort of a dashboard of where your car's health at is. You know, hey, you're going to need new brakes next year. Or your tires are getting a little low. Think about doing that before winter, et cetera. Alerting, this means a key metric is out of band. And so the goal here is to detect an issue and fix it ideally before our customers even notice it, which does mean PagerDuty, sorry. Now, if you're going to have PagerDuty, it's got to be sustainable. So make sure that there is clear, concise on-call documentation. And you always want to write that documentation with the 3 a.m. rule in mind, that someone just got woke out of a beautiful deep sleep. They're not at their best. They have not, in fact, had any espresso yet. And so don't be clever. Don't assume people know what's going on. You should always have this quote in mind whenever you're writing on-call documentation. We don't rise to the level of our expectations. We fall to the level of our training. We really have to think about what we need to monitor an application, what is useful for us. What is a key metric? Now, some of those metrics really are only matter about the infrastructure. So maybe that's CPU utilization, RAM utilization, threads, database connections. That's going to impact more than just my service. There are other metrics that really just matter about my service. And so things like availability, latency, response time, et cetera. This is pretty much anything that we maybe identified earlier as part of our service level objectives for this particular service. So we need to have good monitoring in place for errors and for exceptions. And it's important that we take a step back and ask ourselves, like, what's normal? What's a warning? What's critical? And to be clear, this isn't always easy out of the box. You're going to need a certain amount of history. And this is why having a site reliability engineering team could be really powerful as good leverage for people who've seen this across multiple projects to help you understand what matters for you. Now, it isn't just for prod. This is also something we want to use in staging. And we want to make sure we validate our monitors that it is, in fact, important, and this is helping us with what we're trying to do. Now, any of these metrics should be on a dashboard of some sort or another, and then we should get an alert when something kind of goes out of band, because I don't want human beings staring at dashboards all day. That's not a good use of their time. So anytime something goes out of band, then we want to alert on that. Speaking of which, absence of a key metric is an alertable offense as well. Now, good alerts need to be actionable. They need to be something that a human being can step in and do something. If the app can fix itself, that's not an alert. That's something that maybe shows up on a dashboard or a report that you see later, but you don't need to alert a human being about that. It also should have some sense of urgency to it, that this needs to be fixed soon. And again, it should also require a human to intervene. Again, if the system can heal itself, don't alert that to a human. So if it's fixable, again, let the system figure that out for you. Now, I'm a huge fan of the site reliability book from Google. You can peruse this on the interwebs. It's not something you need to read cover to cover. There's just a bunch of really good essays in here. And one of my favorites is the 4 golden signals. And so they talk about these are the things we care about most on an application. So what's my latency? How long does it take to service a request? What's my traffic level? In other words, the level of demand on my system, request per second IO rate. What's my error rate right now? How many failed requests have I had, whether that's explicit, implicit, or a policy failure? What's the saturation I'm at for some constrained resource? Now we want to think about our sampling frequency, and a lot of us tend to go towards, well, high resolution is always better, right? Give me the highest resolution TV possible, even if my eyes can't possibly tell the difference between this and that. That can actually be really costly for us when it comes to metrics. We can get way too much data, and we can lose kind of the signal and all that noise. So there's a pretty good chance that you want to aggregate that data. Now, there's any number of tools that we can use here, from Wavefront to Dynatrace to New Relic to everything in between. And what we're going to show you here shortly is actually Spring Boot Actuator. It's pretty amazing, some of the things that Spring will give us right out of the box. Now, you can't allow metrics to be this hand-rolled kind of thing. Strongly advise you to take advantage of Actuator's built-in endpoints. There's a number of pieces right here that are very useful, very applicable to your applications. It's actually pretty straightforward to create your own as well. Now, I want to stress that it does take some time to kind of get monitoring right. And yeah, this is why I'm aware, or why I believe SREs have become such a key component these days. I also want to stress that be really cautious with a metric that's easy to measure, that doesn't guarantee it's actually useful to you. And we also need to make sure we understand the business drivers that are going to affect our services. Do we understand what could cause a spike in demand? And then how would that translate to our services? I also want to stress you should be realistic here. It's very easy for us to all think we're going to be a third of internet traffic, but we actually can't be. All right, so with that in mind, I'm going to shut up and I'm going to let Jakob go ahead and demo this for us here and see what kind of trouble that gets us into.
Let me share my screen. Screen number 1. So I haven't had a chance to say hello, good morning, good afternoon, or good evening, depending on where you are. I'm in Poland. Here is 4:25. I guess it qualifies as an early afternoon. I don't know, depending on who is going to be asked. Well, Nate was talking about 12-factor apps. In other words, a bunch of sensible rules that we can apply in ours while doing our software architecture. And I was laughing in my head every time Nate said that, oh, I validated that rule. I'm happy to report that I have personally validated all of those rules, but then I got to know Spring, and Spring tremendously helps to have predefined bits, like, for instance, Spring Boot Actuator, which allows us not to create our hand-roll solutions from things like monitoring. Probably monitoring is a feature that we are going to need in every single place in our system, in every application probably nowadays, as Nate mentioned. So hopefully I'm sharing my screen right now, and you should see start.spring.io. Probably you are familiar with that. So if I want a new dependency, for instance, something which was already mentioned at least 3 times, like Actuator, it's pretty straightforward to add it in here. Well, I will be showing Spring Boot Actuator metrics exposed via HTTP endpoints, which means we'll be also needing Spring Web dependency, so that we have built-in web server like Apache Tomcat, for instance, default embedded container, right? And also Actuator, here you can choose the bits you actually need for your application. And I have already done it before the presentation, and here's how it looks like when it comes to the actual app. I have 3 dependencies you can see. One of them is default, which is a testing tool for our application, and the other 2 are those which were chosen at start.spring.io: starter web and starter actuator. And this is enough for us to be able to use default monitoring features provided by Spring Boot Actuator. I'm talking auditing, health, metric gathering. It can be automatically added to your application, as I said, preferably via HTTP endpoints, but also you can use JMX access if that's your need. So enough of talking. Nate mentioned that hopefully internet gods are with us today. I would add that hopefully demo gods are with us today as well, because we'll do a lot of live coding. So, things can go wrong, but I have a backup plan, like videos. Hopefully we won't be needing those. Well, as you can see, that's a pretty clear Spring Boot application without anything yet. All right. And the only thing which I added is the embedded container and the Spring Boot actuator. All right. If I run it right now, let's do that. We are going to see what kind of things, what kind of information it can give us. But I have a port clash, so probably I need to change my port server.port. Let's do it 8888. All right. And now restart. And now I will go to my browser to see what kind of things Spring Boot actuator gives us without any trouble. 888. So the default path is actuator. You can, of course, change that if you want. So if you don't want this prefix actuator, you can change that to anything you would like monitoring or whatever. For instance, I can take a look what are the beans provided by this application. Of course, Spring Boot default configuration of Spring Boot comes with a predefined set of beans. All of them you can see together with the scope, the type of the dependency, and so on and so forth. I can do things like what's my environment, what's the class path, what's the vendor, what's the for instance time zone, blah blah blah. Of course, probably in your head a question arises like, well, is that secure? You can include Spring security to have out-of-the-box security that is normally used to your business endpoints. So the same things apply here. What else? I can, for instance, check what kinds of caches do I have. I don't think we have any, so that should be empty. I can check, for instance, mappings. So what kind of HTTP mappings are there? You know what? Maybe let's do something like this. I will just add a new bean. It's going to be a REST controller. Let's call it test controller. Why not? And let's have a get mapping, HTTP get / I don't know, maybe test, for instance. Why not? Public string or public void test. It's empty, right? Let me restart the application, and we are going to see that a new bean with new mapping should be visible. You know what? We can also add a scheduled task. So I need to enable scheduling, because Spring Boot actuator allows us to take a look what are the scheduled tasks provided by your application. I will do something like this: scheduled public void scheduled task log, or don't do that on production, please. Task, why not? Let's do it fixed rate each 2 seconds. And now let me restart the app, and we are going to see 3 things. Slash beans with a new bean, because, I have a problem with one annotation. Let me double check that. Yeah, I know why. It's not this app, sorry for that. I should be doing that in here, of course. Let me copy paste. Demo gods, as always. All right, so much better. Let's restart this app. All right, it's done. So now, beans, and we are looking for our test controller. Test. As you can see, it's in here. It's not that complicated. I can only see the scope. We don't have any dependencies because we haven't added any, so that's probably sensible to see. Let's check mappings. I guess it was /test, if my memory serves me well. Yes, it's in here. What's the handler? What's the predicate? What are the details? What is the handler method? And so on and so forth. So I didn't copy paste the scheduled task, but basically if you go under scheduled task, probably. Nope. It should be scheduled task. Yes, but I think I have a typo. If I had added that, we'd have seen that in under fixed rate section. So basically, you can do whatever you want here. This is provided, but as Nate mentioned, we can also add our custom endpoints. And let me do that with one of the endpoints. This time, I will be doing that in the correct application, which is this one. So this endpoint will be providing, I don't know, random numbers, for instance. Why not? Probably not. That's not something we will be doing on production, but this is just a showcase endpoint. So we have to annotate that with add endpoint and add the identification. In this case, I can call it random. By the way, if we want this to be just JMX endpoint or just web endpoint, we can use this annotation, web endpoint, or that JMX endpoint. And then if I do read operation, string void, not void, but string random, we can return, for instance, string value of new random number. And now if I go to our browser after restarting the app, of course, and do /actuator/random, which is the new ID of the ID of the new endpoint, I should be able to see the result of this. Of course, I can also do this write operation if I want to change state via HTTP post. Okay, so it's both directions. I can also change my metrics if I need to do that for whatever reason. Let's check if that actually works. /random. As you can see, I'm seeing random numbers in here, right? Random. So one thing maybe worth mentioning is the following thing. All of the endpoints are enabled but not exposed by default. What it means is that they are included by Spring Boot Actuator, but except for, if my memory serves me well, health, they are not exposed. But if you do some sort of configuration like that, we can actually enable everything, including even shutdown endpoint. Yes, via Spring Boot Actuator, we can shut down our application by doing, for instance, HTTP post /shutdown. So if you want to do some sort of demo with Spring Boot Actuator, please remember that it's not going to work if you don't include some sort of configuration like this. Of course, that's preferably not something that would jump straightly into production, because, well, there are security requirements and so on and so forth. Yes, with that, I think that's enough to show when it comes to Spring Boot Actuator. If you want to know more, Spring Boot Actuator is very well documented. Same applies to other bits from Spring ecosystem. So if you want to know more, please read the manual. That is almost everything that you can possibly imagine when it comes to Spring Boot Actuator. All right, Nate, the stage is yours.
All right, thank you, Jakub. All right, so let me go ahead and spin up my screen share. Speaking of more information, we do have some links to that as well. So there is a lot of information out there, as you can probably imagine. There's a D-Zone piece. There's also, unsurprisingly, some videos that you can find out on the YouTubes. There is, I mean, could you have guessed that Josh would have done a Spring tips on how to do this as well? And then again, there's more videos than you can shake a stick at. All right, so that's Actuator. Now let's move on to another piece that we need for these distributed applications, and that's fault tolerance. Now, as much as we might hope and wish that everything is going to go great, it's just not how the world works. And we realize, to the best of our planning, things are still going to break in production. And what you realize in these highly distributed systems is that they're not islands unto themselves, because yes, a service will fail. To paraphrase my favorite fictional chaos mathematician, failures find a way. And our customers don't care why. Now, the challenge for us as engineers is we can't prevent all bad things from happening, but we can be prepared for it. And so we need to expect bad things to happen, or as an SRE would say, hope for the best, prepare for the worst. So how should we react when a service fails? Should we have an error message displayed? Should we call a backup service? Should we rely on some cache data? Do we just return 42 every time? Now, there are three answers to every question you've ever gotten in computer science. There's the aforementioned 42, which is the check to make sure people are well read. My favorite pattern as an architect is another layer of indirection. But the answer that I have to give so often that I'm seriously ready to just get a t-shirt made. In fact, my friend Mark has a t-shirt on it that says, it depends, because it depends. Now, for us in our highly distributed applications, we're going to have some circuit breakers in place. And so this was originally described by Michael Nygaard and Ship It Back more years ago than I care to admit. Not the only pattern in there, by the way, a lot of great stuff hiding in there. And it's fairly straightforward. It works the same way as a circuit breaker does in your house, right? So if everything is good, we just let it go through. And if it's not, oops, we're going to go ahead and make sure we don't continually call something that's broken. All right, so the circuit breaker watches the calls. Once some failure threshold is exceeded, the circuit is opened. And so now you can't actually complete the circuit anymore, and it redirects to some fallback mechanism that you've already configured. Every so often, it sort of kind of pokes the original service. Are you better yet? Are you healthy now? Oh, you are? Cool. Let's go back to normal. Now, there's a ton of different implementations that you can pick from here. And this is where Spring Cloud Circuit Breaker becomes so useful for us, because we can have the same programming interface, the same API, and then developers can use whatever implementation makes sense or is the right approach for that particular instance. So you've got one API, and then if you want to use Hystrix, great. You prefer Spring Retry? Awesome. You like Resilience for J better? Fantastic. One of the challenges that I faced when I first became an architect was just realizing that I couldn't afford to be dogmatic about things. And so I'll give you one of my favorite examples. I want teams to write tests. I don't care really what they choose to write those tests in, how they choose to do that. I just want them to write tests. And so if I've got a team say to me, oh, Nate, we love JUnit. I'm like, great, JUnit's my favorite testing tool. I'm so glad you like JUnit. If I've got another team that says, we're going to use Spock, I'm like, great, I love Spock. It's my favorite testing tool, because I just want them to write tests. So yeah, you got to have circuit breakers in place. Which specific implementation you use, knock yourself out. So what do? We add the proper starter to the class path, we call the factory, and now we can inject that circuit breaker wherever we need to inside our code base. The beauty of that is they can all be individually configured if necessary, but I can also have default configuration that just applies to everybody. You can change anything you think you need to change: failure thresholds, slow call thresholds, minimum number of calls, your sliding window, etc. You can't have a healthy microservice biome without circuit breakers. And luckily for us, it's not hard to add, and your customers are going to thank you. Well, I mean, maybe they won't notice, and that's kind of our job too. It's sort of like since it's fall here in the U.S. and American football season has spun up. As a former offensive lineman, they only noticed me when I did something wrong, like, oh, you gave up a sack, or oh, you held somebody. It's an unfortunate part of the job. So we don't want to be noticed sometimes. And we certainly don't want to get that 3 a.m. page that wakes us out of a deep sleep. All right, well, I'm going to let Jakob show you how this works. So let me go ahead and stop my share here and hand it over to Jakob.
All right. Let me share my screen again. All right. I guess you can see my screen. So my app just crashed and it keeps indexing. So this time I'm going to use a video for circuit breaking. It's in here. All right. So let's imagine we have a class failing with client. And what it does, it simulates our application connecting to a different application, which is failing. And this is how we are going to simulate the failure. Okay, we are going to call evaluate because, well, that's a risk client. We are going to evaluate risk. And not only we are going to wait 300 milliseconds each time we call this application, but also in 50% of situations, it will fail. So we wait and it will fail. Let's make it even 75%, okay? So this line of code, those two lines of code are going to give us 3 failures out of 4 trials. Of course, it depends, but mathematically, we are expecting 3 failures for every 4 trials. And before each trial, we are going to wait significantly more time than it should be, which means 300 milliseconds. All right. So this is our external, let's call it third-party application. And we have an application which gives us credit cards, grants or rejects our application to credit cards. And we have a get mapping. It's going to be evaluate. And all it does, our application, it delegates to the second application, all right, which is the failing risk client. And now we are going to do a short benchmark of how it actually behaves on production. In order to do that benchmark, I'm going to use a tool which is called AB. Okay. First, let's maybe check if that actually works. /evaluate. As you can see, we got an error. We got an error. We got an error. We got an error. But this time we got okay. 4 trials, 1 success. And let's go back to this AB tool. With this AB tool, we are going to do 100 requests to /evaluate. And then after this benchmark, we can read very interesting information like how long did it take? What was the failure rate? What was the success rate? How many transactions per second did we process, etc., etc. So AB-N 100 trials, localhost 8080 evaluate. As you can guess, this benchmark is going to take at least half a minute. Why? Because we have 100 requests. Each of the requests takes at least 300 milliseconds. That's the latency we artificially added to our call to our failing third-party application, which deals with risk evaluation. Okay, so it soon should be over. And probably we are going to see around, around 20, 25 failed, around 80, 81 to be more precise, non-200 responses, so failures. And as you can see at the bottom of this benchmark, we see what was the longest request, how long did it take? And it was more than 300 milliseconds, 316, okay? So now what we need to do, we need to make sure this is not going to happen, because if the application behaves badly, if we have 3 failures every time we call it 4 times in a row, probably we shouldn't be calling that system anymore at all, and we should immediately return a failure or just a probably manual response or something like that. In order for us to do that, we need to include circuit breaker, which Nate mentioned. Okay. Again, you can do that via start.spring.io or maybe just by adding the dependency. I have added a dependency to Spring Framework Cloud, yes, and then Resilience4J circuit breaker, which is one of the implementations mentioned by Nate. So how it works? Spring comes with an abstraction, circuit breaker, and one of the implementations is Resilience4J. Previously, it was Hystrix years ago, but now it's in the maintenance mode, so we have Resilience4J. It was added, as you can see, so we can proceed and add it to our application. How? It's pretty straightforward. You need to configure that. And with that, I want to highlight something very important. So I'm configuring the circuit breaker factory inside of this controller's constructor, which is for the sake of doing it quickly, okay? Normally on production, we won't be configuring things like circuit breaker in a constructor. That's insane. I didn't want to create much more classes. That this is how it's quicker. So thanks to this line of code, I am able to create a circuit breaker, which we are going to use very soon. But first, we need to do the mentioned configuration. It includes a number of parameters that you can tweak according to the needs of your application. How to do that? As follows. You create circuit breaker config. You can choose default or custom one. The custom one will be probably better for this demo. You can, for instance, change the failure rate threshold. So how many failures until we open the circuit. what's the wait duration in open state, how much time we spend there. Let's do it. Let's do 30 milliseconds, for instance. Why not? Or 100, which is 1 second, 1000, sorry. You can also configure things like what's the size of the sliding window, and many different parameters that I strongly encourage to take a look at when you will want to add Spring circuit breaking to your class path. The same applies to time limiter config. So actually, resilience for J requires 2 different configs. You can change the timeout duration. Again, we are going to use 300 milliseconds here. You can also change the second parameter, which is, that's the only parameter, sorry. And then we'll create the configuration and pass it to our instance of a circuit breaker, which is a field of this class. So first, we have a configuration. Then we have an instance of a circuit breaker added here in the line 35, okay? So here we are going to finish the configuration like this. Probably I can skip that, but yeah, it's quick, so. All right. We need to pass the ID because every circuit breaker has to have a unique ID. We have just one, so ID is enough. And as soon as this is over, the configuration is over, we are able to rerun our benchmark, and you will see what happens. The expected behavior is that the benchmark will last significantly less because, well, most of the time the circuit will be open, which means our clients are not mad at us because we are not forcing them to wait just to see an error, which is stupid, right? This is how you apply the circuit breaking. You can just use a method run, which needs a supplier. A supplier takes the previously used line of code, evaluate. And now we are going to run the application and rerun the benchmark and see if our expectations to how it's going to behave were correct or not. All right, so it still works, but let's do the benchmark. Clear. All right. As you can see, it was significantly faster, less than 1 second. Previously, we had half a minute, right? Of course, we have more mistakes. That's by definition, by nature of circuit breaking. But remember that you can add manual response. So it's so much better to for a client of our application to see an error or a manual response immediately than for them to wait and to see an error and maybe once in a while success if they are lucky enough. So it was quicker, significantly quicker, but we have more non-200 responses. Okay, so I think that's it when it comes to circuit breaking. Of course, there are many things you can configure in here. We were just showing the surface of why it might be needed in your distributed system. All right, that's it.
See, now I love how Jakub shows as we're going, hope for the best, prepare for the worst, and implements his own circuit breaker on what we just presented to you. So there you go. We're doing it live. That's how this works. So let's jump into Spring Cloud Stream. A lot of distributed applications, for better or worse, use event-driven architectures. Now, before we dive down that path, you should probably ask yourself, wait, what do you mean by events? Because this is very much depends on who you ask. Martin did a great piece on this a few years back. What do you mean by event-driven? Because it is a little bit in the eye of the beholder. What it really boils down to is there's a bunch of different patterns. And so it kind of depends on which one you're using. You know, there's event notification, which is something happens and the source system shouts into the void, something happened. So, hey, a new customer signed up, you know, everybody bang on the cowbell. The event emitter doesn't care what happens next. Now, this is cool because it's highly asynchronous, and it is an example of what I refer to as the zeroth law of computer science, which is high cohesion, low coupling. Now, there's downsides to that, which is what would you say you do around here? It can be really hard to debug, difficult to reason about these systems. And that's why we talk about monitoring so much. Also, really easy to lose sight of the flow. There's event carried state transfer, which means the event carries the details along with it. So the customer updates their address. And by the way, here's the new address. So the event subscribers don't have to turn around and say, hey, could you tell me what they changed it to? This is an example of tell, don't ask, otherwise known as object-oriented programming 101. And yes, Martin's written about this too. Imagine that. This does reduce latency and gives us lower overhead on those source systems, but it does mean a lot of data gets tossed around. And of course, the receivers need to know how to handle that state. There's also event sourcing, which is we record every single state change. And it turns out now that this event store is really the record of truth, not so much the database. I actually worked on a system like this a long time ago, but we didn't have this pattern. Kafka didn't exist yet, so we weren't entirely sure what to do about that. We just had a lot of log tables. This is what it used to be. This is what it is now. So yes, Kafka is your friend for things like this, which is basically a really, really strong audit log, makes it really easy to recreate history, makes it easy to run hypotheticals, although evolving schemas can be painful. It can also be really hard to replay when you interact with outside systems. Now, there's also CQRS, otherwise known as Command Query Responsibility Segregation, and wait for it. Yes, Martin's written about that too. In other words, I have one data structure for reads, another for writes, which is not necessarily event-driven per se, but you often see it sort of combined in with these approaches. But you don't have to just take my word for it. Martin goes and expounds upon this much more so than I did here. And we've written about this on the developer portal as well. Now, you might be sitting there going, well, geez, Nate, which one is the right approach for you? And if you were paying attention earlier, you know what I'm going to say next, which is, well, it depends. This is all about trade-offs, but you probably knew that. And this is also when someone usually asks, hang on, Nate, how did distributed transactions work in the cloud? And then I get to rain down cold water on you and say, I'm sorry, they don't. We just don't do that. Frankly, it's like the real world. If you go to your favorite store and you buy a t-shirt because nobody's buying shorts or pants anymore because we only get seen from the waist up. In fact, we have a few new colleagues and for all I know, they don't have legs because I've never seen them in person. So if you buy a shirt at your favorite store, there's a return policy. They don't keep that transaction open until the return policy expires. No. The sale is committed. If you return the shirt, there's a series of compensating transactions that happen that put that shirt back into inventory, issue you a credit, et cetera. That's how this works in our world too. All right, so what can Spring do to help us when it comes to events? Well, there's Spring Cloud Stream. Now, here's the thing. As architects, we want flexibility, right? That's our job. We know there's going to be change. Well, hang on, isn't architecture the things that are hard to change later or the decisions we wish we got right? Absolutely, they are. But we don't want to paint ourselves into a corner. So one of the beauties of Spring Cloud Stream is it allows us to swap brokers so we can make that change later if we need to. And as you can guess, it supports what you'd expect, Kafka, Rabbit, et cetera. You provide the binder to the external brokers. It's middleware neutral. And you can go ahead and integrate a test binder if you want as well. You can build your own binder if you want to. That destination binder will then connect to your messaging system and handle all the boilerplate bits for you so that you can then just deal with the important stuff, which is solving the business problems. Now, I'm going to actually shut up right here so that Jakob actually has a chance to at least show a little bit of this before we have to call it a day. And then we'll see what kind of trouble that gets us into.
Unmute. All right. Correct me if I'm wrong. We have 9 minutes, right? Should be enough. Should be enough. So as Nate mentioned, Spring Cloud Stream comes with a set of predefined binders, and the technology is actually middleware agnostic, middleware neutral. So, but I need to specify which one of those tools, like RabbitMQ, for instance, or maybe Kafka, I'm going to use in my application or set of applications so that they can actually connect to each other. So in here, we are going to use Spring Cloud Starter Stream Rabbit. So I think I cannot stress that enough. So if we have dependency to Spring Cloud Stream, and then we have a dependency to Spring Cloud Starter Stream Rabbit, I don't think that's magical to say that as a developer, I want to use streaming with RabbitMQ. All right, that's why Spring Boot, to be more precise, Spring Cloud Stream actually tries to automatically connect to RabbitMQ instance, which is, by the way, just by accident, running on my local machine right now. So if I start this application, it should connect to a localhost default port of RabbitMQ, which I forgot. I think it's 5762 or something like that. Never mind. We're going to see. So that's the first application. If I have the same set of settings at the other side, at the consumer side, this is going to be a producer. And then at the consumer side, I have the same kind of binder. Guess what? It will try to connect to localhost 5762, probably settings that I'm going to change on production, especially in cloud when there is no localhost, of course, right? All right, enough of talking. Let's see how it works. So I have an application which, again, deals with credit cards. So we have some code predefined, but let me fill the gaps in order for us to see messaging from point A to point B. So maybe each 2 seconds, and I'm going to do that by using scheduled annotation, fixed rate 2000 milliseconds, which I think is 2 seconds, last time I checked at least. If I do, hey, please apply for a credit card, and if this application ends up with a message being sent to RabbitMQ, at the consumer side, we should see something. But let's try to do that first. So I'm going to apply for a card by using this service. Don't worry, let's go and see what's inside. So I have a method apply, which takes identification number. That's a funny story. I don't have time to describe that, but PESEL, it was supposed to be a unique identification number in Poland, but it's not unique at all. And we have problems with that. That's why I'm using that in demos. So the first 2 digits of the PESEL stands for the year in which a person was born. So if I pass 50 something, that means the person was born in 50, and so on and so forth. And we have a very sophisticated risk checking algorithm. If the person was born before 70s, we are sending card application rejected. Otherwise, we grant the card and we send card granted. So domain event publisher is the one who is going to talk to RabbitMQ. That's something we should be taking a look at right now. All right. So as you can see, it's empty, but I'm going to fill that in with code right now. So if I pass source, which is a piece of code which comes from Spring Cloud Stream, add constructor parameters, refactor, good, that you can use in order to specify some commonly seen situation, like I have just one output channel, like here. Well, this is so common that Spring engineers decided to put that inside of the framework. Contrary, you will have sync at the other side, which has one input channel, which we are going to see very soon. Okay, so this is how to add headers to your application, because guess what? Messaging can have headers as well. Why not? And this is it. Source.output, so the channel we specified, send new generic message. That's our payload, the event, and these are our headers. All right. So if I haven't done any mistake, each 2 seconds, we are going to see a rejection for an application for a card. Let me double check if that's correct. So in the meantime, I'm going to run the application, and let's take a look at the other application, which is the consumer. Consumer is here. So this is how to receive information at the other side. I'm not going to show you POM XML because it looks exactly as the one we already have seen. It has 2 dependencies. This is how you specify to the framework that, well, this one should be invoked every time there is card granted, and this one every time there is card application rejected. And we check that by headers, to be more precise, to the type we pass on the producer side. All right. So as you can see, the second application, the consumer, sees the periodic statement with rejection each 2 seconds. So it was fairly easy to add this messaging bit to our 2 Spring Boot applications. Notice that we haven't specified anywhere in the code base, I mean in Java code, that this is Rabbit.
All right. Unfortunately, we had to cut off Nate and Jakob because they were just going wild there. Some great material for sure. Please go over to the Slack channel in the Spring One Slack and continued the conversation with them. They have a lot to say, and it was great content for sure. Definitely made a lot of those same mistakes that they talked about in my journey as well. But we'll be back with another great session in a couple minutes.